Okay, today we're looking at factoring polynomials. In the next section, we're going to be solving quadratic equations using some factoring. So that's one reason we throw this in the mix between graphing them and solving them. Hopefully you've seen some of what we're going to be looking at today and before in Algebra 1. We're going to look at special cases of factoring. Then we're going to look at factoring trinomials and then factoring completely using a mix of special case and trinomial. So the first thing, let's look at special cases. Okay, the first special case is called the difference of squares. And what's a dead giveaway? It's a difference of squares is you're going to have two terms. And recall that a term is simply something added or two things added or subtracted. So they're always separated by plus signs or minus sign. That's how you know it's a term. So I could have like 12 x squared, y squared, z is a whole term. 49 is a term, x is a term, so on. Okay, another clue that you have difference of squares is you're going to have a minus sign. And your exponents are even or divisible by 2. So exponents, you can say exponents are even. And all of your numbers are perfect squares. Somebody give me an example of a perfect square. What's a number you can take the square root of? So examples of perfect squares are 4, 9, 1 is also a perfect square. What's some more? You got 4 squared, 16. And then 25, 64, 49, so on. So a perfect square is simply any number you can take a square root of.
Like 3,364.
Oh, what's that? What is the square root of that?
58.
Oh, okay. Yeah, I cannot do that one in my head. Okay, let's go. We'll go ahead and talk about the sum or our next special case, but we're going to focus on difference of squares first. Next special case is called the sum and difference of cubes. The sum and difference of cubes. So notice that if you're dealing with perfect squares, I only have the difference of squares. If you like, sum of squares is not a thing. It's what we call prime, and it's not factorable. So only the difference of squares is factorable, but when we get to cubes, the sum and the difference of cubes is factorable. So once again, what you're looking for here is you have two terms. You can have a plus sign or a minus sign in the middle. Your exponents are divisible by 3. Exponents are divisible by 3. You can go back up and make a note too. Exponents are even. That just simply means they're divisible by 2. So that's what you're looking for if you want to do it that way. Divisible by 2. You don't have to. Okay. Now, your numbers have to be perfect. What? If we had perfect squares, then these numbers have to be perfect cubes. And what makes a number a perfect cube is you can take what's called the cube root of it. How many of you have a calculator, either scientific or graphing? Doesn't matter. Get it out. I'm going to show you how you can find the cube root of a number on it. Guys, you don't have to write this next part down. Well, hang on. Yeah, maybe write this part down. I'll talk about the calculator in just a second. Okay, let's talk about what numbers are perfect cubes. 1 to the third power is 1. 2 to the third power is what? What's 2 times 2 times 2? 8. What's 3 times 3 times 3? 27. What's 4 times 4 times 4? There you go. And then 5 times 5 times 5 is 125. 36 times 6, or 6 cubed is what? 216. And so on. So perfect cube is just simply what you get when you raise a number to a third power. Okay, in your calculator, this is the part I was telling you you don't have to write down. In a calculator, you may see this button. It'll have X, and then it will have a root or radical sign. So if you want to, and that allows you to change the index other than taking the square root. You can take the third root, fourth root, fifth root of a number. And the way you do that is you would type in like 3, then hit that key. Let's say you want to find cube root of 64, then you would hit equal, and it should come out to 4. Does anybody's calculator not have that button? That has one with you? On your phone, you may have that too. I know on my graphing calculator, I have to actually go into math. So if you have a graphing calculator, you may have to go into the math function that you should see, and then you may actually even have a cube root like key that looks like that, or option. So if you don't know perfect cubes, and most people tend not to, you might use that to help you find them, or you can Google a whole sheet of perfect cubes. Okay, let's practice some, and then we'll move on to factoring trinomials. You want to make sure in all of these problems that you factor them completely. Sometimes if you factor once, it may keep breaking down. Does anybody need to go back up? Okay. Okay, m squared minus 64. So when you're factoring, you're either going to factor trinomials, which have 3 terms, and they factor a special way. You have this binomial, which only has 2 terms, so it may be a special case. Or you may have 4 or more terms that you factor by grouping, and we're saving that for another time. So in our situation here, I have 2 terms, and we're looking to see, is it the difference of squares or the difference of cubes? Which one is it? It's a difference of squares. It came close to being the difference of cubes. What kept it from being cubes? Good. That exponent being divisible by 2. So we know we have difference of squares. And this is the way difference of squares factored. And I should have made a note up top before we kept writing. Difference of squares, you're going to have 2 parentheses. And you will always have different signs. Always different signs. One's a plus, one's a minus. You get the first term by taking the square root of the first term. The easiest way I know to tell you is for variables, you're going to divide that exponent by 2. So what goes here? Good. M to the first power or just M? You don't have to write this down unless you just want to. So square root of the first, or well, of both terms really. The square root of both terms is really how you're getting the factor part of it. All right, what's the square root, or what goes here? Square root of 64 is 8. So once you figure out you have different squares, you take the square root of both things, you have different signs. You could put the minus sign first. It does not matter. Okay, have you guys done that before? Difference of squares?
I remember something like that.
Something like that? Okay. As long as you slightly even recall it, that's good. Okay, on number 2, don't be thrown off by such crazy looking terms, okay? This is still one term, and this is still one term. What's a dead giveaway? You only have 2 terms. Good, you only have one minus sign. If I had another plus or minus sign, then I would have 3 terms. So anyway, I know I have 2 terms. So the only thing I can see if they have something in common to pull out first. Do they have anything that you can factor out? Like in other words, both of them would have to have X, Y, and Z or something like that in order to factor it out. And you don't. So you're checking for a special case. This is minus sign. All of your exponents are what? They're all even. Is this number a perfect square? Can you take the square root of 169? Yes, you get 13. So it is a perfect square. Okay, what are your signs? We know it's difference of squares. So what signs do we put in the middle? Good. And I'm just going to put a minus here and a plus here to show you that it does not matter what order. Okay, what is the square root of this part? Or if you just divide those exponents by 2 is really what you're doing. So what goes here and here? Good, x2, y2. And then you have to take the square root of this part as well. divide your exponent by 2. So what goes at the very end? Good, 13 and z, 13z. Always check and make sure that neither one of these will keep factoring down. Well, this is a sum. And 13 is not even a perfect square. They don't have anything in common. Same thing here. I don't have anything in common I can keep factoring out. And you're going to see what I'm talking about in just a second when we do one of those. Okay, do y'all have any questions so far? Okay, now going back to cubes, we'll say the sum difference of cubes. You have a formula. Okay, if you see that you have the sum of 2 cubes, this is how it factors. You'll have 2 parentheses. One will have 2 terms. Second one will have 3 terms. This sign is the same. The sign in the middle is always opposite that first sign. So this is a minus sign in this case. Last sign is always positive. How you get the first terms, you take the cube root. You're going to take the cube root to get the first term and the second. Or in other words, you're going to divide those exponents by what? Good. You're going to divide your exponents by 3. So A and B go here. So this is your formula. Take the cube root of any numbers, divide exponents by 3. And that sign will be the same. Okay, for the second set, you're going to square those first and last terms to get these. So square whatever's here and whatever is last to get your last term. And the middle simply comes from taking A and B and multiplying them together. You do not care about signs. All you're looking to see is what is A and what is in B spot, and you're multiplying them to get this. You don't care about sign because you already determined the sign based on what this one is. Okay, let's talk about your formula. Let's use that same knowledge. This is your formula to help you factor difference of cubes. Tell me what would go here based on what you have up top. This sign is always the same, so this is going to be minus. And you take the cube root, so this is A minus B. What will this sign be? going to be a plus sign, and this sign at the end is always plus. I square A, and I square whatever's in B spot. And I multiply A and B to get that middle. All right, let's look at this one. Y cubed minus 125. You may think that's the difference of squares on first glance, but tell me what two things make it not difference of squares. Mm-hmm. And what else? 120. Can you take the square root of 125? No. But if you type in your calculator cube root 125 equal, you'll get 5. So you have an exponent divisible by 3, perfect cube. So this is difference of cubes. Okay, what sign goes here? Good. The first sign's always the same. First same, first same, first same. The second sign is always the what? The opposite. Last sign is always plus. Good. So if I were you, I would go through and put all of my signs before I do anything else. Okay, now let's divide this exponent by 3. So we have what here? Y. Let's take the cube root of this, and you get 5. Now that we know that first parenthesis, you use this to get your other terms. You have to square y. So that just becomes y squared. And then tell me what you get at the end. You have to square 5 as well. So you get 25. And then the middle, all I do, I don't pay attention to the signs. I just take 5 and A, which is Y. So I take this and that and multiply it together. So 5 times Y is 5Y. Okay, y'all, any questions about that? Have y'all ever factored the difference of cubes, sum of cubes? Okay, I didn't think you probably have. Okay, see if there's anything that can factor out first. Do these two have anything in common? They both have a what? They both have an A. What's the lowest exponent of A that they have? Does that make sense or no? All right, they both have at least an A. So when you're factoring out variables, take the one with the lowest exponent. So this is A the first, that's what I bring out. And then they both have a B to the first that you can factor out. Okay, what are you left with? If you factor out, so pretty much what you're doing, when you factor out something, you go back through and divide by it to see what you're left with. So if I factored out A and B, you don't say you're left with 0, but you would say what? If you factor out an entire term, you're left with 1 in its spot. Okay, you took out an A, so you have A to the, you factored out 1A, so you have A squared left inside. Do you have a B? No, you do not. Okay, this is really close to being the difference of squares, but you don't have a minus sign. If that was a minus sign, you would have difference of squares. But this is as far as you can go. So sometimes the only factoring you can do is simply what does each term have in common. Okay, in number 5, does either term have anything you can factor out first? They don't, do they? No. Zen, are you good? Well, that's nice on so close. They don't have anything you factor out. You do have a minus sign, so it's either difference of squares or difference of cubes. All of your exponents are not divisible by 2, so it's not difference of squares. All of your exponents are divisible by what? 3. So the exponents are divisible by 3. You have 64, which is a perfect cube. So here we have difference of cubes. So factoring problems can be really simple, or they can get kind of involved and have a lot of nasty variables like this, and like you're going to see in a little while. Let's go ahead and divide. So in the front, or well, what are your signs? You should know that first. What's your sign here? Minus. The second sign's always opposite. This last sign's always plus. Okay, I get my terms from taking the cube root of both of those, or in other words, dividing all your exponents by 3. So this gives me r squared, s squared. What's the cube root of 64? 4. Good. Be very careful. I'll have a lot of students get mixed up and say, oh, that's 8. Taking the cube root of it. So I get t to the what? Divide that exponent by 3, so you get t to the 3rd. To get this first term, you square that. Think about it like this. If you were multiplying r squared to r squared, what would you get? Like if you have r squared s squared times r squared s squared, do y'all remember what you do with exponents? Good, you add those. So if I'm squaring, if I'm raising that to the second power, I'm simply just multiplying those exponents by 2. That's all you're doing. So when you square it, multiply your exponents by 2. And I have to square this, so I'm going to multiply my exponent by 2. So I get t to the what? 6th power. Good. And then you have to square 4 as well. So what goes here? You have to square this whole entire chunk. 16. That's okay. Like a lot. I do that too. Like I'll actually multiply by 2 instead of squaring it. What'd you say, Zinder? T? Yeah, it looks like a plus sign on it. Okay. Finally, let's get this middle term. You take 4t cubed and you multiply it to that. So you're going to write all of that together. 4r squared s squared t cubed. God.
Yay.
Yeah, it is too close to a plus sign. Okay, how do y'all feel about sum and differences of cubes and squares? Okay, we're going to look at some trinomials. Hopefully I think this next part will probably be more familiar to you than that. Did y'all enjoy getting to sleep in this morning? I mean, I know I'm with you on that, but I always enjoy some extra sleep though. I don't know what.
I forgot about it and I woke up and I saw it. Oh no.
What makes a polynomial a trinomial?
The exponent.
It's not the exponent. It's the now that you see me writing some up here, what do you think makes it a trinomial? You got 3 terms. You'll have 2 signs, plus, minus, whatever, and you'll have 3 terms. Okay, this first trinomial, those type are the easiest factor because you have 1 out front. These trinomials are a little bit harder to factor because you have to take into account any leading number in the front. The easiest thing I know to tell you about factoring trinomials like this, if you have a plus sign at the end, So let's say plus at the end. Then both of your signs in parentheses will be whatever's in the middle. Both signs come from middle. And then you're looking for a sum. And you'll see what I'm talking about in a minute. Both signs come from the middle, and you're looking to see, you want sum of the middle term. If you have a negative at the end or a minus sign, you're going to have different signs. So one will be a plus, one will be minus. And you're going to look at two numbers that subtract. So you want a All right, let's look at this, and we'll start off with 1 in front, and then we'll move on to where we have another number in front. A squared plus 10a minus 75. All trinomials are going to factor into 2 parentheses. What sign do you have at the end? Or well, you've got a minus at the end, so what's going to go inside? Tell me what your signs will be. Good. Since I have a minus sign, these are going to be plus and minus. It does not matter which one you put where. You can put the plus sign in a second. Okay, what I meant by subtract, since you have different signs, you're looking for 2 numbers at the end. They have to multiply to 75, but they have to subtract to your middle term 10. So try to figure out 2 numbers that multiply to 75 that would subtract to 10. So the factors of 75 are what? Like 25 and 3. What about 15 and 5? Is 15 times 5 75? Yes, and 15 minus 5 is 10, right? Okay, so your bigger number, 15, has to go with your plus sign because your middle term is positive. These 2 numbers should always, like positive 15 times negative 5 should give you negative 75. Positive 15 plus negative 5 should always give you that middle every time. You need to check that. I can't tell you the times that people will factor and then they don't check their work and get it wrong. Now, in the front, all you have to do is take the square root of this or divide that exponent by 2. You can check your work. What are you undoing when you factor? You're always undoing what? Like, how can I go from this back to that? You could FOIL or distribute. You're always undoing the distributive property when you factor. Because if I FOIL this back out, you don't have to do this. I'm just showing you, so don't write this down unless you want to. First, it will give you a squared. Outer will give you minus 5a. Your inner would give you positive 15a. Last would give you minus 75 when you multiply them together. And so when you combine like terms, You see that makes 10A. Yeah, so you can pull the check, or you can just check the last and your outer net. Okay, 7. Okay, add that X to the 4th on. Yeah. Hang on, scratch that. It's not working out how I want it to. Okay, there we go. Okay, is there anything that they have in common you could factor out first? Do they all have an X? No, they don't all have a Y. They do not all have a Z. And this number is 1, so you can't factor out any numbers as well. You do have a trinomial. So if it factors, it's going to factor into 2 parentheses. This is still one term. That's still one term. Don't let all the jumbledness throw you off. Your last line's minus. So what are they both going to be? Good. One's going to be plus, one's going to be minus. All right, let's go through and figure out our variables before we worry about the numbers. So in the front, you know that you always take the square root of this first term or divide all of your exponents by 2. So what goes in the front? Good, X and Y. Let's look at this variable on the end before we worry about 50. I also have to take the square root of any variables at the end as well. So what goes here and here? Z goes at the end. Now to figure out what the number is in front of Z, I have to determine two numbers that will multiply to 50 and will have a difference of 5. One reason you're looking for a difference is because you have different signs. If they were the same sign, you would be looking for a sum. Okay, two numbers multiply to 50 that subtract to 5 are what? 10 and 5. You have to make sure that 10 goes with your bigger number, goes with your plus sign because your middle term is positive. And you can double check this. Your last two things should multiply to negative 50z squared. They do. Your inner will give you negative 5xyz and middle positive 10, and that'll make your middle term. Okay, now for numbers that have or trinomials that have a number in front other than 1. Okay, in this problem, you have 7 in the front. In order to factor these type problems, the first thing you're going to do, or the method that I use, is I take this number and I'm going to multiply it to the end. Some teachers have their own method. So we're left with c squared minus 8z and 12 times 7 will give you 84. Okay, now I factor this just like we did in the last problems. Okay, we're looking, tell me what my signs will be. Good, and I'm just going to put the plus sign here, minus, doesn't matter. I'm looking for two numbers that multiply to 84 that subtract to 8. What are the factors of 84? You've got 84 divided by 2 will give you what? 42. That definitely will not subtract to 8. And then is 42 divisible by 3? 3 will go into 42 14 times. That will not subtract to 8. And then you got 4 and what? 21 will not subtract to 8. Is 84 divisible by 6? It is or not? What is it? What do you get? Okay. And that will subtract to 8. So tell me which number goes where? 6 has to go with the plus sign. 14 has to go with the minus sign because that middle term was negative. And I put C in the front, divide that exponent by 2. Okay, now that we have it factored here, this is what everybody forgets. Since we took that 7 and multiplied to get this, you have to now go back and divide each of these numbers by 7. You will simplify anything that can. So tell me what your first parenthesis becomes. This becomes C minus what? 2. Good. And then can you simplify 6/7? No. This won't simplify. So what you do with anything left in the denominator, it moves in front of that variable. And so this becomes 7C plus 6. Anything on the top, you leave it in that spot. Anything left on the bottom moves in front of that variable. Now to double check, 7C times C is 7C squared. These first terms have to multiply to that. If they don't, then you've done something wrong. Your last two numbers have to multiply to this number. -2 times 6 is -12. And then look, notice if you check your outer, that will give you 6C. If you check your inner, that's -14C, which does make, how did I all of a sudden switch from C to Z? Anybody catch that? That should be C. My bad. That should be C too. So sorry. I'm sure some of you are like, why is there a C and a Z in that? So 6C, that's, anyway, that does give you that. Okay, y'all ready for, all of these have been minus signs at the end. So here you go. Here's the last problem of the day. This is plus sign at the end finally. Because you're gonna love this one. Just wait till I write it up. You have 2x raised to the 6th n power minus 11 x to the 3n power plus 14. Okay, this, they don't have anything you can factor out. 2, 11, and 14, nothing in common. They all don't have an x, can't factor that out. It's a trinomial, so it factors into 2 parentheses. You have a plus sign at the end, so both of them are going to be what? Both of them will be, they come, if you have a plus sign at the end, both of your signs come from that middle sign. Oh, we didn't do something first. Okay, I have a leading number, so I'm going to multiply it to 14. So sorry, should have done that before I wrote those giant parentheses. So this will leave you with x to the 6n minus 11x to the 3n plus what? 28. Okay. All right, so this is what we have now. We have this to factor. It's 3 terms, so still do it just like you know. Don't let the 6n and the 3n throw you off. Okay, so in the front, tell me what we do with those exponents. You divide them by what? When you take the square root, like if I had x squared right here, what would that become? X. So in the same manner, I'm simply going to divide this 6n by 2. What will that give you? Good, I heard somebody say it. You'll get 3n. And then at the end, I don't have any variables to worry about, so we're good. Now I've already taken in account to that variable in the exponent, and I don't have any exponents or variables down here. Let's focus on our number that we need, and we'll be done. Well, after what 2 numbers will multiply to 28 and add, since you have the same sign, you're looking for a sum, they have to add up to 11. So you have 2 and 14. 3 will not go into 28. Then you have 4 times 7. Is 4 plus 7, 11? Yes, and I don't care where 7 and 4 go because they're both the same sign. So you don't have to worry about that in this case. Now, what's our last step that people, including me, forget to do? You have to divide 7 and 4 by what? 2, that number that we took and multiplied. This will not simplify, so where do you move to? Good, you have to move 2 in front of that x. So you get 2x to the 3n minus 7 in that first parenthesis. And this will reduce to what? What's 4 divided by 2? Or what do you get? 2. So that completely reduces to 2. So you get x to the 3n minus 2. Okay. All right. Your assignment for this is on paper. And you need to look at your assignment link because you don't have to do all of those problems. Your worksheet's going to look intimidating. You're going to have like, there's 35 plus 23. There's a lot of problems on your worksheet, but I only gave you like 19 from them. And I'm making it due Wednesday to give you plenty of time to get that in. I didn't want to do something with you on Thursday and then make it due on Sunday night. So look in your 4.4 folder, and I'm going to post solutions for that worksheet soon too. Ellie, hey, please, ma'am. Okay, so I was looking, and I thought I responded to your email, and I don't think I ever did.